Hello, today we will talk about the properties of stock options. Okay. Uh, in the last class we talked about the options market in general. Okay. I think they have some notation, perhaps it makes it a little more confusing than it needs to be. So small c stands for the European call option price, large C stands for American call option, P European put option, capital P is for American put option, S0 is the stock price today, ST is the price at maturity, T is the life of option, sigma is the standard deviation of stock prices, R stands for the risk-free rate of interest. Okay. So before we move on to anything else, I think it's important to go back, and when you exercise a call, what you get here is the maximum of the stock price and the minus the strike price minus the call premium. So that is the formula that tells you what you get when you exercise a call. Now what does it mean? So basically here what it means is that you will exercise the call only when the stock price is greater than the strike price. Otherwise, what you do is that you just walk away. So that is why whenever the stock price is less than the strike price, it means that you walk away and what you get is zero, and you already paid for the call upfront. So that is something you have to subtract. Now what about the put option? That is given by the maximum of 0 and the strike price minus the stock price. So here what we have is that the difference between the strike price and the stock price minus the put premium. So I think it's very important to make sure you are comfortable with these two formulas, that is what you get when you exercise a call and what you get when you exercise a put, and that is perhaps the central deciding factor in later chapters. Okay. So here what we have is that it talks about the factors that affect the option prices. So here we have 6 variables. These are the stock price. S0 stands for the stock price. Okay. Then we have the strike price. K is a strike price. Then we have the time to expiration. T is the time to expiration. Sigma stands for the volatility or the standard deviation of the stock prices or the underlying asset. R is the risk-free rate of return, and the last one is the dividend. So let's look at each one of them at a time. Okay, and let's go back, and so first one is, let's talk about the stock price. And what we see here is that an increase in the stock price will increase the call premiums. Okay, so that is pretty the reason why it happens is because what you get is the difference between the stock price and the strike price. So here let's say the stock price is 60, the strike price is 58, you get $2. When the stock price is 62 and the same strike price, you get $4. So here we see that as the stock price increases, the call will also go up in value. The next one is the strike price, and what it tells you is that as the strike price goes up, the call premium will go down. So here let's look at this example. When the strike price is 58, you make $2. When the strike price is 60, you make nothing. Okay, so that is why the higher the strike price, the cheaper is the call price or the call premium. The next one is the time, and what we are saying here is that let's compare two options, one which expires in June and the other which expires in July. And what we see here is that the one that expires in July can do all that the one that expires in June can do, but we also have one more month left, and that is basically because of that you have more flexibility, and chances are perhaps you can make more money from the option. So that is why the longer the time, the higher would be the typically the call premium. And let's look at the next one. The next one is the standard deviation or the volatility. And what we see here is that the higher the standard deviation, the higher is the call price or the call premium. And why does it happen? So if you buy a stock let's say you paid $60 for that. As the stock price goes up, let's say to 65, you make $5. If it goes down to 55, you lose $5. If it goes to 45, you lose $10, and so on. On the other hand, if you bought a call on the same stock, what we find is that, let's say you paid $5 for that. So on the upside, as the stock price goes up, you make money, and the downside, the most you can lose is the call premium. So that is why what we find is that when you buy a option, the profit and loss is not symmetrical. The upside potential is high, the downside losses are limited. So that is why when you compare that with the regular stock, for a regular stock, what we typically study in finance is the higher the risk, the higher is the expected return, and what that tells you is that the lower would be the price you want to pay. On the other hand, for an option, what we find is that the higher the risk of the option, the higher is the price that you want to pay. The next one is the risk-free rate, and what we are saying here is that the higher the risk-free rate, the higher would be the call price. Now, why does it happen? The reason why that happens is because what we'll see is that what you get from exercise is the difference between the stock price and the present value of the strike price. So what it means here is that you can control the stock as long as you buy a call option on the stock and you have enough money in the bank so that you can exercise the option. And here, the higher the risk-free rate, the less money you need to have. That is why what we find is a positive relationship between the call price, the call premiums, and the risk-free rate. And the last one is the dividend, and what we are saying here is that the higher the dividend, the lower is the call price or the call premium. Now, why does it happen? The reason why that happens is because when you buy a call option, suppose the underlying stock pays a dividend, you will not get the dividend. The person who holds the stock today, he or she will get the dividend, and because of that, we can expect the stock price to go down by the amount of the dividend. So here, the higher the dividend, the lower would be the call price or the call premium. Now, we can do the same thing about the put prices, okay? And let's go and talk about the put price. And I think the main thing here you want to think about is what is the formula we want to use, and that is given by maximum of 0 and the strike price minus the stock price. Okay, so this is the formula. So what that tells you here is that the higher the strike price, the lower is the put price. And what it means here is that the higher the stock price, the lower is the put price. So here, let's say 60 is a strike price, the stock price is 58, you make $2, and if the stock price is 59, you make $1. So that is why the higher the stock price, the less money you make and the less you want to pay for that. Now, what about the strike price? So the higher the strike price, the more you make, because here for 60 minus 58, you make $2. Now, if the strike price is 62, you make $4. So what we find here is that the higher the strike price, the higher would be your profits, and that is why you also should be paying a higher price. Okay. Now, what about the time? Typically, what we say is that the higher the time or the longer the time, the more valuable the option is. The next one would be the standard deviation, and the logic is still the same as the call. When you buy a put option, what you're looking for is the upside, and on the downside, if it as the stock price goes down, you make profits, and as it goes up, you lose money or your losses here are limited. So again, that's why the higher the standard deviation, the higher is the put premium. The next one is the risk-free rate, and what we see here is that the higher is the risk-free rate, the lower would be the put premium. And the last one is the dividend. What we find here is that the higher the dividend, the higher would be the put price. Now, why does it happen? The reason why that happens is because we are saying that, let's say the stock price of $4 dividend, we expect the price of the stock to go down by $4, which means that when you exercise the option, you're going to get more money. So that is why, or we can say that suppose you own the stock and you bought a put option. If the stock pays a $2 dividend, you can get the dividend and then you can exercise the put. So you can sell the stock to somebody else. So these are the variables. And I think the main thing here is that all these variables, they basically come from the Black-Scholes option pricing model. So all of them are derived from the Black-Scholes, and these relationships tell you how the option price changes with these variables. So chances are, I think you get some short questions from here. So definitely you want to make sure you're comfortable with applying these type of formulas to find out the the relationships. Okay. Now here we are talking about American versus European option, and American option is worth at least as much as the corresponding European option. So what we see is that in the case of the American option, the main advantage is that you have the ability to exercise early, and in some situations it can be valuable, in other situations it may not give you anything much. So but what we are saying here is that at a minimum the American option should be at least as worth as the European option. The same thing for the put option. Now here we have the lower bound for European call option prices, no dividends. And what we said before was the call is given by stock price minus the strike price. So that's what we said, maximum of 0 and the difference between the stock price and the strike price. So this is what happens at the end. Now what happens before the end? So suppose you are 3 months before maturity, what would be the value of the call? What we are saying here is that that is given by the stock price minus the present value of the strike price. So here this is one way to find out the present value of the strike price. In the textbook they are using the continuous compounding, so that would be the stock price minus k e raised to minus rt. So k e raised to minus rt is almost the same as k divided by 1 plus r raised to t. So both of them talk about the present value of the strike price. So here we are saying that the European call should be worth at least as much as the difference between the stock price and the present value of the strike price. Now what about the put? So in the case of the put option, what we said was for the put is given by maximum of 0 and k minus s. Okay, so here this tells you the formula. So at maturity, basically this is what you do. You decide whether to exercise or not depend upon the strike price and the stock price. So what we see here is the strike price minus the stock price. That is what we want to look for. So if it is positive, it is greater than 0, we want to exercise, otherwise we walk away. Or another way to say is that if you exercise the put, basically what we are looking for is we can sell the stock for a price that is higher than the current stock price. So here let's say this exercise price is 60, the market price is 58, you want to exercise the put option. On the other hand, if the exercise price is 60 and the market price is 62, you will not want to exercise the put option because you get a higher price in the market. And here what it tells you is that if you what is the value of the put before maturity? So the value of the put before maturity is given by P is greater than or equal to the present value of the strike price minus the stock price. So here this is the present value of the stock price, the strike price, and in this case we are using regular compounding, k divided by 1 plus r raised to t. Now as far as the most important thing that we look for in this chapter is we talk about the put call parity. So what is the put call parity? So what it tells you is that if you own a stock option, if you buy a stock and if you buy a put option, that is the same as the present value of the strike price plus the call price. So this is the put call parity relationship. Stock plus put is equal to the present value of the strike price plus the call price. Now what does it mean here? Sometimes when you talk about the present value of the strike price, that is, we can think of that as a bond, and here what it tells you is that the stock price plus the put price is equal to the call price plus the present value of the strike price, or here that is a bond with a face value equal to the strike price. So one thing we want to make sure is that for both the call and the put, all of them have the same strike. Okay, so have the same K and same maturity. Okay, so we are talking about the call and the put on the same stock with the same strike price and the same maturity. And here it tells you that stock plus put is equal to the present value of the strike price plus the call price. Now how can we check that? So let's look at the case where you know, uh, we are looking at a call. Okay, so let's say the strike price is 60. Okay, and we are buying a call option. Okay, and we bought a bond. Okay, so let's say the stock price is greater than 60. So let's say the stock price is 62. And for the call option, what you get is $2, 62 minus 60. Okay, so if the stock price is 62, you get $2 on the call, and the zero coupon bond is going to give you $60. So overall, you end up with 62. Now, what about the other portfolio where you have the share and you buy the put option? So here, the share you have is worth 62, and the put option is worthless. The reason why it's worthless is because the stock price is greater than the strike price. So what we find here is that both these portfolios have the same value. Now we can also look at the case where the stock price is less than the strike price. So let's say the stock price is 58. So when the stock price is 58, the call is worthless. The zero coupon bond is going to give you 60. So overall you end up with 60. Now what about the put option? The put option you bought, that is going to be, that has a strike price of 60. So 60 minus 58 is going to give you $2, and the stock is going to be worth 58. So your overall value is going to be $60. So what we see here is that when the stock price is greater than the strike price, put call parity seems to hold, and when the stock price is less than the strike price also, the put call parity should be holding. Okay, so all that I did here is that I gave you some numerical examples rather than the formulas. But like I told you before, this is a very important relationship, and it tells you the relationship between the stock price, the put price, the call price, and the value of the bond. Okay, so that is the put call parity. So here, stock plus put is equal to present value of K plus C. So how do you figure out the call price? So the call price is given by S plus P minus present value of K. And what it tells you here is that you can, if you go to the market, you cannot find the call you want, or you find that the call is overpriced, you can create a call option. And how can you create the call option? You buy the stock, you buy a put, and you borrow the present value of the strike price. Now how about the put is given by the present value of K plus C minus S. Okay, so how do you create the put option? You buy the call, you short the stock, and basically you're depositing the money in the bank. Okay, so that's what we see here. So, I think we'll talk about this in the next class. We'll talk about some numerical problems where you might have to find out the call price given the stock price, the put price, or you might be asked to find out the put price given the call price and the stock price. So here, the put call parity relationship tells you that the stock plus put, P plus S0, is equal to C, the call, plus the present value of the strike price. So K e raised to minus RT, that stands for the present value of the strike price. So that's what we see here. And the first term is the call, and then we have the put price and the stock price. So another way to say is that the present value of strike price, essentially what we are saying is that it's like buying a zero coupon bond with a face value equal to the strike price. So call plus bond is equal to the stock plus the put option. So the last thing we want to talk about is we want to talk about early exercise. So usually there is some chance that an American option will be exercised early. So when do you think you might want to exercise an American option early? So the first example would be, let's look at the case where a non-dividend paying stock. So basically here what we are saying is that if you look at an option, so when you buy a call option, that has two parts. So that has the time value plus the intrinsic value. And if the stock does not have a dividend, what we are saying is that you never want to exercise the option early. Why is it that you don't want to exercise the option early? Because if you exercise it early, you are giving up something, and that is you are giving up the time value. Or another way is to say that in the case of a call option, typically what we say is that if it is on a non-dividend paying stock, we always say that an option is worth more alive than dead, because by exercising you are killing the option. On the other hand, by selling it, you are keeping it alive, and that will have more value. So when do you think you want to exercise early? Typically what we say here is that you will want to exercise early if the dividend that you get is higher than the time value. So here, let's say the dividend is $2, okay, and the time value is like $1. Clearly it makes sense for you to exercise early and capture the dividend. Okay, so basically this summarizes what we just talked about. No income is sacrificed. You delay paying the strike price, and holding the call again provides insurance against stock price falling below the stock price. So the main thing here is that you're not giving up anything by not exercising. And another thing is that if you are keeping the exercise price, the present value of the exercise price, by getting more time, it basically helps you grow your money. Now, what about a put option? When do you think you might want to exercise a put option early? So one of the places where we might want to exercise early is that typically, we don't want to look at the numbers and so on, but basically, typically what people say is that when the stock price has gone down substantially, and basically what we are saying is that we don't foresee any more decrease in the stock price. So at that time, you might want to exercise the put, because waiting is not going to give you anything more. So here, if there's a dividend, what is the impact? The call price is given by the stock price minus the present value of the strike price minus the dividend, and the put is given by the strike price minus the stock price plus the dividend. So these are the lower bounds when there is a dividend being paid. And what it talks about here is that it talks about the put call parity for American option, okay, and it also talks about the European option. Now, as far as we are concerned, I think you only have to worry about the case where there are no dividends, and we are talking about European options. Okay, so I think we don't want to go back and summarize the things we talked about in this chapter. Okay, so I think the main things we talked about in this chapter are, we talked about the properties of stock options. Okay, so this is what we did. We talked about the variables that affect option prices, and these are the stock price, the strike price, the time to expiration, the standard deviation, the risk-free rate, and the dividend. So there's a very high chance you get some short questions based on that. How are call prices affected, and how are put prices affected? Okay. We also talked about the lower bound for European call options. So C is greater than or equal to stock price minus the present value of the strike price, and for the put, that is given by present value of the strike price minus the stock price. And perhaps the most important thing we talked about here was the put call parity. And what we said was that if you buy a call and if you buy a put on the same stock with the same strike price and the same expiration, so this is very important, the same strike price and the same expiration, what it tells you is that if you buy the stock and if you buy the put option, that is the same as buying the call option and having the present value of the strike price in the bank. So stock plus put is equal to the present value of the strike price plus the call price. And here this illustrates why put call parity holds. And why do we care about that? One of the reasons why we care about that is because if you look at these securities, if you go to the market and find that either the put is overpriced or you cannot find it, or the call is overpriced or you cannot find it, in both those cases you can create the security you want by combining the other three securities. So how do you create a call? The call is given by the stock price plus the put price minus the present value of the strike price. So to create the call, you buy the stock, you buy the put, and you are basically borrowing the present value of the strike price. How do you create the put? So to create the put option, you buy the call, you short the stock, and you deposit that in the bank at the risk-free rate. So these are, I think, the most important concepts from this chapter. Okay, so I'll